Hello everyone, welcome to another lesson in My 2015. We're going to be looking at rigging this catapult. We built this catapult in our class earlier, and now it's ready to be rigged. We're going to use a joint system on the catapult arm. So we're going to start with some joints. So to create a joint system, you have to use an orthographic view because the joints want to be locked down to two axes. If you use a perspective view, it'll just kind of throw it out there, kind of base at your camera angle, but not where you want it to be at in most cases. So we're going to select our orthographic view, and from our side view, we're going to go to Skeleton, Joint Tool. Now, I know I kind of jumped in this. I forgot to mention that we're underneath our animation subset. So if you are in polygons, make sure you switch to animations. Otherwise, the skeleton option with the joint tool won't be available to you. Okay, so once you select the joint tool, you'll have these little crosshairs here, and we'll select near the center here, and that looks good for our first joint. You'll just see a little glowing green thing here in the middle. We're going to select one more spot right near where the catapult arm rests. And we're going to select one more spot at the end of the catapult arm. And we'll hit enter. That'll complete our chain. Now we got to name all of our joints. So joint 1, I'm going to name as BN root. Next one is going to be BN bend. And the last one will just be BN end. Okay. So we got our 3 joints, and now we are ready to build a control for them. Right now, if you go up and down on it, the joint goes up and down. This one over here, if you select this one, it also bends. But we don't have any control over it. And if you look at our control arm, the joint system is hiding on the inside of our catapult arm. So we need to create a control that will control this guy. So we're going to use the CV curve tool to create a custom controller that will give us good visual output of our rotation of our joints here. So again, we're going to jump back into our orthographic view because to create the points for our custom control, we also need to be locked down to two axes. So I'm going to select my orthographic view. And please excuse me for just 1 second. My dog wants to go outside. Just 1 second. Sorry. Okay. Of course, he wants to go outside when I start recording a video. All right, so we're going to use the CV curve tool, and the CV curve tool is always available underneath Create. So we're going to go to Create, CV curve tool. And I'm going to put the submenu on this guy. Sometimes you'll have it underneath cubic. That'll make kind of a rounded curve. For this situation, I want it to actually be sharp, so I'm going to leave it on linear. I also want grid snaps on. This is because I want the curves to kind of snap to each one of these crosshairs on the grid. So I'll turn this magnet with the grid on there. It's grid snaps. Go ahead and use that. And I'll go to the center here so I can make sure that what I'm making looks somewhat correct. All right, so starting over here, I'm just going to draw out an arrow kind of cross shape. And the shape of this doesn't really matter. Any curve will do the job that we're kind of after, but doing this will make it to where, as I'm rotating the arm, it'll make it to where I can see the rotation of the curve, which translates to telling me that my my arm rotations are working the way I'm thinking. It gives me visual output so I can make sure that everything's working the way I want it to. Okay, hit enter to complete this guy. And I'll call this one CTRL for control, and we'll call this one what is it? Base arm. And I can see over here, somehow I messed this name convention up. This one is not joint bone root. It must have kept part of the original name, so there we go. Bone root. Alright. Back to this controlled base arm. It's over here. I need to translate it. Turn grid snaps off. Bring it over here. Okay. Now I want to snap it to this joint down here. So I'm going to hold down V and middle mouse button drag the center area and drag it to where this joint is. And there's a vertex on the inside of this joint hiding in there that it'll snap onto. Perfect. There we go. And I'll move this off to the side. Okay. Perfect. Okay. Now I'm going to need to freeze the transformations from where it's currently at before I go any further. So I'm going to go to freeze the transforms. I go to modify, freeze transforms. Okay. So now, and actually I should have rotated this a little bit first because I want the arrow to kind of point down the chain with my joints. So as I'm rotating it, I can see like that this as this goes up, it'll bring this up as well. Just it makes visual sense to me. So again, I'll freeze transforms. There we go. All right, and I created a layer to put my controls on. So I'm going to select this guy here, and I'm going to add him to this controls layer. That way it's bright red so I can see it. Makes it nice and easy for me to grab my controls. They're hidden up. So, I mean, the joints are hidden inside the geometry, so it makes it to where the purple is kind of hiding inside here. Like if I had Byron shaded, it makes it to where things aren't confused with those lines. Okay, so we need to create another control for our middle joint here. This is the bend. So I'll just select my last one I created. I'm just going to go Control D, and we'll vertex snap that one up to this upper joint here. Okay, and I'll just translate that over a little bit. Good. All right, and I'm going to call this one Control Bend. Perfect. Alright, and I need to freeze the transforms on this guy as well. So I have my little icon here for freeze transforms. Again, you can find freeze transforms underneath modify, freeze transforms. I like to just keep all the tools I use on my shelf. That way I don't have to keep going underneath the drop downs. Okay, so since I created this one from the original, it just automatically got passed down the chain. So it's now already added into this controls layer, so I'll have to add it in there. That's perfect. Okay, so now let's skin this guy. Let's see here. So I got some constraints going on here. Quick connections. I think I might have used this particular control or particular model for a demonstration earlier, so I'm having to undo a couple things. Anyways, alright, so I want this control arm to be controlled by this joint here, so I gotta skin it in. So I have the mesh selected. I'm gonna shift select the root of the joint here, and I'm also going to select the second joint. Usually you don't have to do that, but for some reason sometimes I keep running into issues where if I just do the root joint, it doesn't actually skin all the way through. So I mean, let's just go ahead and try and do it the way it normally goes, which is you select the geometry, you shift select the root, and you should just be able to go to skin. Okay, that's probably the reason why. I need to have my, I must have been doing some custom work earlier on where I was working on a control rig. If you reset the settings, when you go to bind to, it should say joint hierarchy here. I think that I had it on selected joints. It's the reason why it wasn't working for me earlier. Sorry. If you have it just on selected joints, then it means that it won't work for the whole hierarchy. Okay, so this is ready to go. So go ahead. We selected the mesh first, shift selected the joints, and now we just hit apply. And now when I rotate this guy here, it rotates the whole control arm. When I rotate this guy here, it rotates this guy, so that's perfect. Now all I got to do is work on my constraints here for this this joint down here. So I need this control to control this joint down here. So I'm going to select control, shift select the joint, and I'm going to go to constrain, parent constraint. So now when I grab this control here, when I translate it forward, it moves everything. When I rotate it, it rotates everything. And that's exactly what I wanted. Okay? Alright, so let's go and look at our next control up here. We are pretty much doing the same thing here, except for this time we're only going to do a orient constraint. So we're going to select this guy here, we're going to shift select this one, and we're going to go to constraint orient, and we're going to open the submenu. I always have maintain offsets on. I think that by default is turned off, but you need to have maintain offsets turned on, otherwise this joint here will kind of snap to whatever angle the curve's at. So we'll leave maintain offsets on, hit apply, and everything stays as it should. And now when I rotate this guy, it rotates this guy for us, which is what I was after. Okay, and now we just need to address one more problem, which is when I rotate this guy, my other control doesn't come in. It makes it to where this this arm bends because it's trying to keep with the orientation of the control down here. So we need this control to follow with this one. So we're going to make this control a child of this control. So this one's selected first, which is the child, and this one's the parent, so I'll shift select this one and I'll hit P. So always child first, then parent. So now as I rotate my parent, the child goes with. Okay. Great. Okay. So let's take a look now at doing a rig for the overall body down below here. Now I'm going to do something a little bit different, and the reason why I'm doing this is because let's say you want to take this catapult into a game engine. Game engines require there to be joints to animate things from outside packages. The geometry and the control curves don't carry any animation information. Is what carries the animation information is the joints. So if we don't have one in controlling each part of this catapult, then this catapult won't be animated if you were to bring it inside of a game engine. So we're going to create a single joint that will control all of the base of our catapult here. So I'm going to go to create. Oh, no, I'm sorry. We're going to go to skeleton, joint tool, and we're going to go to our orthographic view. And we are going to put a single joint just right here in the center. That's all we need. We'll just call this one BN Catapult base. Okay. All right. And I will select everything, which I have this separated up into a total of 6 pieces. We have our catapult arm, we have 4 individual wheels, and we have our winch assembly here, and then we have our catapult mates. So I made all these parts here into one piece, as you can tell here, and I'll shift select that one joint, And I'll go skin, smooth bind. And now since there's only one joint, all the influence for this entire rig is put on this one joint. So it's not going to bend at all because one joint controls everything. But it does make it to where the animation information from this catapult translating forward will carry through to any kind of game engine. So now if I move this guy, it brings everything with it. And if I was to bring this into a game engine, all these animations would carry in. Okay? Alright, so now we need a control rig that controls our single joint here. So again, I'll just borrow another one of these off this guy here. So I'll just Control D and pull off one of these guys. Turns out this guy comes with a partner, so I'll just have to delete off the extra one. Okay. And I'm going to do my best to kind of rotate this guy to where it looks like it's pretty flat. Since I froze the transforms on it, that rotation angle is going to be a little bit off, but I can snap it to my winch arm, and that should help me get somewhat of the look I'm after. Okay. Not that I'm going to bind it to it, but just use it as a frame of reference. Okay, that looks about good. Alright, so I'll move this one back and down, and then I'll scale it up. Alright, that looks about good. And I'm going to freeze transforms. So modify freeze transforms, or if you want to add it to your shelf, just go to the freeze transforms, hold down Control Shift, left mouse button, and it'll pop up on your shelf as this guy here. So freeze transforms, and I'll call this one Control Main. And now I want my control main to control this joint here. So I want it to control the rotation and translation values. So I want a parent constraint on this joint, which is exactly what a parent constraint does. It controls the translation and rotation values. So I'll shift select this guy here and go to constrain parent. And as you can see over here, the translation and rotation turned blue. Perfect. Okay. So now when I move this guy forward or side to side, this guy goes away. Great. Now I need to bring in the pieces I've already constrained in addition with it. So this control over here, the one that controls the rotation of the catapult arm, that one needs to be brought in to this control main. So I'm going to shift select the control main. So this is what I did is I said that this arm here, this rotation of this arm, is a child, and it's going to be parented in to this control main. So I shift selected the control main, and now I'm hitting P. And now as I rotate this guy back and forth and translate it forward and back, it all comes with. Great. Okay. So now I have to take a look now at this winch assembly. Okay, so this winch assembly, now this can be kind of tricky because the winch assembly, you want your joint and your rotation to be based off of the center, and you want to make sure that the fact that this is all may or may not be completely centered. You'll soon find out as soon as you start to rotate this guy. If it starts to wobble a little bit, you'll know that something was a little bit off, but we'll do our best to make our winch rotate good. So again, we're going to create a single joint to drive this guy. So we're going to go back into our joint tool, go back into the orthographic view, and we're going to jump into the side view. And this joint that we're going to drop in, we're going to want it to be this one here. I can already see that the handle is just a little bit off. This little crosshair is right here. This is actually where I want it to be at. That's actually the center. I just vertex snapped it. Hold down V, middle mouse button in the middle, just dragged it so it's right in these crosshairs. I can see this circle right in here, and like this is where I want it to be at. Okay. Now I'm going to select the whole winch assembly, shift select that joint, and do a constrain, parent constraint. So now when I grab that joint, let's see here when I rotate it. I might have messed up a little with something. Oh, I did it backwards. Haha. Okay, it was the other way. But no, that should have been right actually. Maybe I skipped a step is what happened. Yeah, I think that's what happened. I actually didn't want this geometry to control this. I don't know why I thought that. Let's create a control that will control it. I think I jumped ahead a little bit. Okay, so we're going to borrow this guy up here. We're just going to control D, duplicate it out. And we'll bring this guy down and we'll vertex snap it, hold down V, middle mouse button on this joint here, and we'll translate it out, rotate it. Oops. Okay, good. Okay, so now I need to freeze the transforms on this guy, freeze transforms, and I'm going to call this one control winch. Alright, and then we're going to shift select this joint here, and we're going to do a constrain, parent constraint. So now when I rotate this guy, it rotates. But you can't see it yet because I didn't skin this thing yet. I think that was the step that I jumped last time. So I'm going to select this this winch assembly, shift select this joint here, and that's what I did. I did it backwards to break off these connect. Or no, I'm sorry. A little bit all over the place. Sorry about that. Selecting the geometry from the winch, shift select the joint, go to skin, smooth bind. I think I got myself a little ahead and turned around just because I constrained the joint before I skinned it. I saw those constraints already on the joint. Okay, so now when I rotate this control curve, now we have the winch turning. Perfect. Okay. Now we want to add this joint or this control curve into the master control. So we're going to shift select the control here. So this was the child, this is the parent, hit P. Now when I select this master control, I can translate this one forward, rotate it side to side, and still maintain all of my controls functioning the way they're supposed to function. Okay, great. Alright, so we have one more thing to do, and then our catapult is completely rigged, and that is dealing with the wheels. And the wheels need to rotate as this guy moves forward. So we're going to use an expression to drive these wheels. Right now they aren't going anywhere, but we're going to start out by making sure that for one, these guys are, the pivot on is centered. So so you can see right now that as I selected the gimbal, the rotation gimbal is right on the center. That's where we want it. And if it wasn't, I would just go to center pivot, and it would be right where it needs to be. And I'm going to freeze the transforms and make sure it says mesh wheel front left. Naming convention is going to be really important with expressions. And we're going to parent this guy in with our other control here. So I'm going to select this guy, shift select this one, and hit P for parent. Now when I translate this guy forward, this one goes for a ride. And I can realistically go around and do this to all of them right now and save myself a step. So now I'm going to go ahead and do that. Just speeding up the workflow. Okay, so now as I go forward, my wheels come along, but they're not rotating yet. So now we're going to use the expression to drive these guys. So let's go ahead and open up our expression editor. And that is located underneath Windows, Animation Editors, Expression Editor. Okay, perfect. So first thing we're going to do is this, the driven object. and we're going to rotate it. I can see that's rotating my X, and we're going to be translating it forward in Z. So we're going to say mesh wheel front left, rotate X, and you see how it pops up over in here. It says selected objects and attributes. So since we selected the X, that is right here. And I'll select all this, hit Control C, and put it down inside my work area. And I'm going to say this is going to be equal to, and it has to be the right name. So it has to say control main. So mine says control uppercase main. Oops. Control C, Control V. This is going to be equal to CTRL underscore main dot translate Z divided by parentheses 3.14 times 100 bracket semicolon. That will end the line. That is how code ends, is with a semicolon. So now our expression is ready. So all we should have to do is hit create, and we should have our expression. So let's, as long as everything is done correctly, we should be good. And I have a syntax error. So something was done incorrectly. Let's see here. Mesh wheel front left dot rotate X is equal to control main. Okay, so I forgot a semicolon, or not semicolon, a parenthesis. There we go. There we go. Now we have our expression. Everything matters inside of expressions. If you miss something, and your expression just won't work right. Okay, so let's take a look here. If I grab my control main and translate it forward, there we go. My wheel's moving forward and backwards. Perfect. Alright, so I got to do this to the rest of them. So I'm just going to scurry along on these ones and keep on going. So rotate X. Just going to copy this one. Control C, Control V. It's equal to, and we'll call this one control main dot translate Z divided by 3.14 times 100 parenthesis semicolon. Alright, let's give it another go. Good. Alright, so let's see if that all worked good. Still only green. Good. Let's do this one more time. Rotate X. Copy this. Control C. Control V. Is equal to control main dot translate Z divided by 3.14 times 100. And these values, like 3.14, that comes from pi. The 100 value, that was just from a little bit of trial and error. Didn't take long to figure out what looked good and what needed to change. Okay. Alright, so go ahead and hit create on this one. Alright, test it out. Still good. Alright, last one. Rotate X, Control C, Control V, equal to translate, oh sorry, gotta remember the name first. Control main dot translate C divided by 3.14 times 100 bracket semicolon. Okay. Last one. Oh, I have an error. Oh, forgot that. Parentheses. There we go. All right, so now we can close our expression editor. So now as we drive our catapult forward, our wheels go with it. That's great. Everything is still functioning the way it should. These can all be animated individually to have our catapult arm throw things like fireballs and whatever else fun thing would be to throw, like sheep or your neighbor. Okay, so that ends the rigging section of this catapult. Hope you enjoyed the lesson. Hopefully it was helpful. Next lesson, I think that we'll go ahead and create some fireballs to throw, and we'll work a little bit with dynamics and build up some things to throw fireballs at. I think that'd be fun. So thanks for watching, and I'll see you guys in the next lesson.